Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about orthographic projections of the solid. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the isometric 3D projection of a solid, and in the isometric projection the front face, the top face and the side face, they have all been combined in a single 3D drawing. Now the objective is that now we have to convert this isographic 3D projection of the solid into the orthographic projection. That is, we are required to draw the front view, the top view and the right hand side views of this particular solid. Now, in order to develop the orthographic projections, we need to evaluate the size of the front view face, size of the top view face and the size of the side view face. Now, by looking at this isometric construction of the solid, so let us evaluate the sizes of these three faces. Now, from the front, so this is my front view, the width of the solid appears to be 60 millimeter for this face and 40 millimeter for this face. So the total width of the solid happens to be 60 plus 40. It is equal to 100 millimeter. While the height of the solid, this height of the solid is given to us as 60 millimeter. Please check. This is the height of the solid which is equal to 60 millimeter. So the front view face on the orthographic projections will measure 100 millimeter by 60 millimeter. Now let us work out the top face dimensions. So in the top view, we are again going to get the width equal to 100 millimeter, and in the top view besides this width, we are also going to require the depth of the solid, and the depth of the solid is available to us as 50 millimeter as indicated over here in the isometric projection. So the top view face will be measuring 100 millimeter by 50 millimeter. And then the side view, once we are looking at the solid from the side, so the two dimensions which will be required, they will be the depth of the solid which is equal to 50 millimeter and the height of the solid which is equal to 60 millimeter. So the side view face will be having the dimensions 50 millimeter by 60 millimeter. And now let us work out what are the faces of the solid which will be viewed in the front view, top view and the right hand side view. So when we are going to look at the solid from the front, we are going to look at the solid in such a way that three faces will be visible to us. Face A, so this is the face A shape which will be visible to us, and this will be represented as a true shape on the vertical plane. It is parallel to VP. Whereas this face B, it happens to be inclined to VP, so its projection on the vertical plane will be appearing as an apparent shape or a foreshortened or a reduced shape over there. Then there is third face, face C, and this face is again parallel to VP, so the projection of face C onto VP will be true shape. Now let us look at the solid from the top. So once we are looking at the solid from the top, so four surfaces they will be visible to us. Surface number one, this will be a rectangular face which will be visible to us corresponding to this lower block. So this is the lower block of this particular solid, right? So this will be our surface number P over here. Then the second surface is surface R. So this is again same surface as B, but now this is being viewed from the top. So since we are going to view this from the top, so we have named the surface as surface R over here. So the projections of surface R onto the horizontal plane will be appearing as an apparent shape because this surface R happens to be inclined to the horizontal plane. Then you have surface Q. So surface Q is having the shape of a rectangle, and this surface Q happens to be parallel to the horizontal plane. So the projections of the surface Q onto HP will represent the true shape of the surface. And finally there is an inclined surface over here, this one. So we have named this rectangular inclined surface as surface X, and this surface S will be presented onto the horizontal plane as an apparent shape because this rectangular face, it happens to be inclined to the horizontal plane. So surface R and surface S, they will be developed onto the horizontal plane as apparent shapes. Surfaces P and Q, they will be obtained onto the horizontal plane in the top view as true shapes over there. Now once we are looking at the solid from the right hand side, so three surfaces will be available. Surface number 1, so it is this surface, and since this is parallel to the profile plane, so the true shape of surface 1 will be observed onto the profile plane. Then you have the surface number 2, which is an inclined surface. So since this rectangular inclined face, it is inclined to the profile plane as well, so the surface 2 will be appearing onto the profile plane as an apparent shape. That is, a reduced shape will be available on the profile plane. And finally we have the surface number 3 over here. So surface 3, it is a rectangular shaped surface, and since the surface happens to be parallel to the profile plane, so its projection on the profile plane will be appearing as a true shape. So now, having discussed different faces which are appearing to us or which are visible to us in the three views, now let us start with the construction of the orthographic projections of this particular solid. Now step number 1, we need to draw the XY reference line. Then we will be proceeding with construction of the X1 Y1 reference line, which is the intersection of the profile plane with the horizontal plane and the vertical plane. Whereas the XY reference line, it is the intersection of vertical plane with the horizontal plane. So here, since the right hand side view is to be drawn, so right hand side view will be drawn onto the left hand side. So front view will be drawn above the XY line, top view will be drawn below the XY line, and right side view will be constructed onto the left hand side. And this is our transfer line, which will be used to transfer all the distances from this top view, that is distances related to the depth, they will be transferred using this transfer line onto the right hand side view. So these are the three faces which we had discussed will be visible to us in the front view. Surface A and C will appear as true shapes. Surface B will be appearing as apparent shape onto the vertical plane in the front view. Now another 4 surfaces are available in the top view. Surfaces P and Q will be available to us in the top view on the horizontal plane as true shapes, and surfaces R and S, they will be appearing on the horizontal plane in the top view as apparent shapes. And finally you have 3 surfaces from the side view. Surfaces 1 and 3, they are parallel to profile plane, so they will be appearing as true shape in the profile plane, whereas surface 2 will be appearing as apparent shape on the profile plane in the right hand side view. Now in the front view, we know the dimension of the front view rectangular face is how much? It is equal to 100 millimeter. This is 60 and this is 40. So 100 millimeter, it is the width of the solid, and what is the height? Height of the solid is equal to 60 millimeter. So we have got 100 millimeter as the width and 60 millimeter happens to be the height of the solid. So the rectangular face corresponding to the front view of the solid has been obtained, and this width has been projected onto the top view because the top view dimensions will be requiring the width and the depth. So we have also now drawn the depth of the solid. The depth of the solid is available with us as 50 millimeter. So the top view face, it is going to measure 100 millimeter by 50 millimeter. So this is 100 millimeter width and this is 50 millimeter the depth of the solid. Now this depth will be transferred using this transfer line onto the right hand side view. So now once we extend this horizontal line, so this rectangle corresponding to the right hand side view, so this has been completed. So the dimensions of this rectangular, you see, face, this will be 50 millimeter, it is the depth. So this depth has been taken from the top view, and the height, it is equal to 60 millimeter. So height is equal to 60 millimeter, right? Now let us start with the construction of the front view. So the front view, you see, we can divide this width into three parts. Please check. This width is equal to 40 millimeter. The width of this web, this is the vertical web. This vertical web width is given to us as 20. So 40 plus 20 plus 40 gives us 100 millimeter. So I have divided this into 40, 20 and 40. This first 40 from the right hand edge, it pertains to this particular surface C. Then my width of 20 millimeter, which I have shown over here, this pertains to surfaces B, Q and R over here. And finally this width of 40 millimeter, this pertains to the surface number P. Now if we are looking at the solid from the front side, so there is a web which is having the width equal to 40 millimeter. So please check, this web which is appearing on the left hand side, it is having the width equal to 40 millimeter and the height of this web happens to be 20 millimeter. Now I have constructed this left portion of the web over here, right? So this portion of the web which is appearing on the left hand side has been constructed. First of all, height I have marked as 20 millimeter. The width has been marked as 40 millimeter over here. So this height has been transferred onto the right side view because this will be available as a dotted line as we are going to look at this particular web from the right hand side. So the projection line has been drawn even in the right hand side view. Now the next thing is, having drawn this 20 millimeter web, now two more things I want to draw. That is, please check, there is a sloping surface which is going to start from height of 40 millimeter and this slope will continue till you reach the total height of the solid, which is equal to 60 millimeter. That is, there is a rectangular face B over here which is starting at a height of 40 millimeter. So I have started, you see, marking this height equal to 40 millimeter. So this is my height of 40 millimeter and this surface, starting point of the surface B has been marked over here. This is my starting point of the surface B, and once I draw this particular edge, now this square which I am able to see, it's not a square, it is a rectangular face. Please check, this is a rectangular face which appears as a square in the front view. So this is the apparent shape. Okay, so this is the apparent shape, and once I draw this particular line or the projection line, now you can check I have been able to obtain the true shape of the face A over here. This is the true shape of the face A which I have been able to obtain, and the apparent shape of the surface B has also been obtained. Now I need to obtain this slant also. So this slant will be obtained once I am able to locate this right hand corner point of the slope. So right hand corner point, it is at a height of 38 millimeter. So please check, the right hand slope of this particular inclined surface, it is going to end at 38 millimeter height and it is going to start at 60 millimeter height. So starting from 60 millimeter and it will be ending at 38 millimeter. So I will be drawing this slant edge over there. So this surface will be appearing as an edge in the front view. So surface number 2 or S will be appearing as an edge over here. So once I draw this line, we can see this is the shape of my surface C, which is again a true shape. Now let us join the different edges in the front view. So as I told you earlier, this is my shape of surface A, right? This is my true shape of the surface A as it is being obtained in the front view. This is the apparent shape. This is a rectangular face we can observe, and this rectangular shape is being observed as a square in the front view because of the inclination. So this surface is an apparent shape of surface B. Now surface C, again it happens to be parallel to the vertical plane, so there is the true shape of the surface C. So surfaces A and C, they represent true shapes. Surface B represents the apparent shape. Now let us draw the top view. So these projections, you see, I have extended from the front view into the top view. Now I need to draw, please check, corresponding to this vertical web. Corresponding to this vertical web, there are two portions. One portion is surface Q, another portion is surface R. So surface Q is having the width is equal to 20 millimeter and the depth is equal to 30 millimeter starting from the rear side. So starting from the rear edge, this is my rear edge. So starting from the rear edge, I move 30 millimeter forward. So this is the distance of 30 millimeter moving forward. So as I move forward 30 millimeter, this is my rectangular face corresponding to the surface Q. So this is my surface Q which has been obtained. So true shape of surface Q has been obtained, number one. Number two, true shape of the surface P has been obtained. And apparent shape of the surface R has been obtained. Once I draw this projection line over here, this is the apparent shape of this rectangular surface R over here. So this will be projected as an shortened view. Then I need to draw the top view projections corresponding to this web. So I know that the depth of this web over here, it is equal to 20 millimeter. So corresponding to this, please check, I have marked the depth equal to 20 millimeter from the rear edge. So this is my rear edge or the rear face of the solid. This is my rear edge or the rear face of the solid. So from the rear edge or the rear face, I'll be moving forward 20 millimeter up to a distance of 40 millimeter. So this is 40 millimeter width and 20 millimeter is the depth from the rear surface. So this is my rear surface. From the rear surface, I have moved 20 millimeter forward and then this is the width. So this is again my apparent shape of the surface S over here. So all the surfaces and the top view, they have been obtained. Now let us start darkening those faces. Surface P, it is this surface that is having a width of 40 millimeter. Please check, this is the width, this is the width, and having a depth of 50 millimeter. So this is the depth equal to 50 millimeter. So 50 millimeter is the depth of the surface P, 40 millimeter is the width of the surface P. So true shape has been obtained. Now this rectangle is going to contain two surfaces. Once I draw this edge over here, because of the change in cross section, at a distance of 30 millimeter from the rear side. So at a distance of 30 millimeter, this rectangle, it is a true shape corresponding to surface Q, and this square, it is a apparent shape which has been obtained corresponding to the surface R over here, because this surface R happens to be inclined to the horizontal plane. And finally, it is this web projections over here, that is the depth is equal to 20 millimeter, width is equal to 40 millimeter. So this is a rectangle, again an apparent shape, because my actual slant rectangle is bigger than this one. So this is apparent shape, this is apparent shape, and these two P and Q, they represent true shapes of these two faces onto the horizontal plane in the top view. Now let us draw the side view. So in the side view, you can check, I have got this surface over here. So the projection lines, they have been obtained, and once I join all these things, this is again a rectangle, this is again a rectangle over here, big one, but from the side view it will be appearing as a shortened one. And what will be the size of this rectangle? Please check, height is equal to 38 for the lower rectangle. So for the upper rectangle, the height will be 22 millimeter. Please check, this is the height equal to 22 millimeter. So this will be the height 22 and the depth will be equal to 20 millimeter. So height 22 has been marked in the front view and this depth 20 has been marked in the top view over here. So this has the height has been marked 22 in the front view and this depth of 20 has been marked in the top view. Now this is the portion rectangle, and the rectangle number 3 over here, it is this one. It is the true shape. So this, if I join, so this is going to be the true shape of my surface 3. So surface 2 is an apparent shape, surface 1 is true shape, as well as surface 3 also happens to be true shape. And now corresponding to this change in cross section, please check, there is change in cross section over here. So at a height of 20 millimeter, so this lower web top surface, this is going to generate a dotted edge over here. So this is a surface which is corresponding to top surface of the web which is lying on the left hand side of this particular solid. If we are going to view it from the right side, so this will be viewed as a dotted line from the right hand side. So this is dotted line at a height of 20 millimeter from the base, right? So this is the complete construction. Surface 1 and surface 3, they are the true shapes. Surface 1 and 3 and surface 2 will be represented as an apparent shape in the side view, right? So this is the complete construction of this particular solid. Now I have removed the labeling of these faces so that the better understanding of the orthographic projections can be obtained, and similarly all the markings of the faces, they have been removed from the isometric projection as well. So this way we have been able to develop the orthographic projection, that is front view, top view and the right hand side view of a solid whose 3D isometric projection was provided to us. So I hope that through this discussion you would have clarified about the procedure to obtain the orthographic projections over here. Now please check another thing I have done, because the total height was given to me, so I had divided this for the purpose of simplicity or getting more insight into this construction of orthographic projection. Because if I show the total height and these two, this adds to the redundancy over here also. 50 is there, 30 and 20 I had mentioned. Over here again it was 60, 40 and 20 over here. So the extra dimensions now I have removed, so that now the complete construction could be obtained regarding the orthographic projection. So we will be continuing with the discussion regarding few more examples of the orthographic projections in the coming lectures. So this is all for today. Thank you very much. Thanks a lot.